Why are electric circuits valuable to people? People often wonder about how much energy they use. The more lights we turn on, the more energy we will use. Where does that energy we use go? When we plug in an appliance, we are using electrical energy to do work. Often, this involves transforming the electrical energy into another form of energy. For example, if we plug in a heater, electrical energy from the outlet is transformed into heat energy. If we plug in a fan, the electrical energy is transformed into mechanical energy, which is like movement. If we plug in a television, the electrical energy is transformed into light energy and sound energy. In each case, it may appear that the electrical energy is being used up. However, it's actually being transformed into other forms of energy. Did you know that electricity is a flow of charged particles? How did the charged particles flow in an electric circuit? Can the direction of this flow change? Explore how electricity flows in a circuit and find the other forms of energy that electricity can take. So we have two circuits here. We have where the power source will go and the light bulb. So if we look at these two batteries, we have one that has the positive end on the top and the negative end on the bottom, and the opposite for the other battery. So if I put this first battery into the first circuit, it lights up because it's a complete circuit. Now notice that the electrons, which are charged particles that come from an atom, are moving around the circuit. It goes in a complete circle. It starts from the negative side, goes around, and goes to the positive side. So this one is going counterclockwise. Now if I put this one in, think about what we just said, that these batteries are opposite, and tell me, do you think that this circuit is going to also go counterclockwise, or do you think it's going to change directions and go clockwise to light up the light? If you guessed or hypothesized that it was going to switch to clockwise, then you're correct. It's still going out the negative side, and the electrons are traveling through. They go through the light, change to light energy, and then the electrons flow back into the battery. Electric charges are flowing in opposite directions in each circuit. This is because the electric charges always flow from the negative terminal of the battery to the positive terminal of the battery. So we have different objects here that start off using electrical energy, and they transform it into something else. So first we have a loudspeaker. So you plug the speaker in, the electrical energy goes in, and what type of energy comes out? If you said sound energy, you are correct. A loudspeaker turns electrical energy into sound energy. That was loud. All right, a fan. We plug the fan in, and what type of energy does it transform into? That's right, motion. And we also know, because we're fourth graders, that motion energy is actually known as mechanical energy. So this fan is now having mechanical energy. That's great. An electric fan turns electric energy into motion. A toaster. We plug the toaster in. Does the toaster make light or make heat? If you said heat, you are correct. That's great. A toaster turns electric energy into heat energy. And last but not least, we have a neon light. If I plug the light in, then it's going to light up. A neon light turns electrical energy into light energy. The last thing we're going to talk about today is how there are two different types of circuits. So remember, a circuit just means that it's a circle. It goes from a power source to something that the energy can transform into. So maybe a light. It needs to have a power source like a battery, and it needs to have a light, and it needs to be a complete circuit for it, a circle for it to be a circuit. So now we're going to break circuits up into two types, series and parallel circuits. You probably have seen strings of lights on outdoor patios or holiday decorations. What happens if one of the light bulbs burns out? Do all of the lights go out or only one light? The answer depends on what type of circuit is being used. There are two main types of circuits. They're called series and parallel circuits. The first circuits that people used were series circuits. Today, parallel circuits are more commonly used, the more commonly used circuit of the two. In a series circuit, all of the electrical devices attached to the circuit are positioned in one after the other. Charged particles must flow along in a single path. If any of the electrical devices stop working, the circuit is broken. So a series circuit, if you think about a circle of wires, and you have a battery, and the electrons flow out of the battery, They go in through one light, go into a wire, in through another light, go in through a wire, into another light, wire, back to the battery. So that would kind of look like Christmas lights, where it goes in one big circle of just a bunch of light bulbs. The next thing is parallel circuits. In a parallel circuit, each electrical device is attached to a branch of wire that connects to the main loop. If one electrical device fails, the charged particles travel through the other branches. The circuit remains complete. It is a bit like having a detour because the road is closed. You drive along another road to get back to the path you wanted. So this is kind of like having a bunch of circuits connected to one battery. So we're going to watch two videos to help us understand the two of them, and then I'm going to let you guys do the simulation to practice series versus parallel circuits.
There are two major types of circuits: series circuits and parallel circuits. The type of circuit depends on how the parts of the circuits are arranged. This is a series circuit. Notice how all the parts of the circuits are connected one after another.
Making a complete
There's
circle.
only one path for the current to travel. You predict. What will happen to the circuit if this wire is disconnected from this bulb? As you can see, not just the bulb to which the wire was connected went out, but all the bulbs went out. This is a big disadvantage of series circuits. If there is a break anywhere in the circuit, the entire circuit fails to work. Fortunately, another type of circuit solves this problem. When a light goes out in this chandelier, the other bulbs don't go out. When a light in this chain of lights goes out, all the rest of the lights stay lit. And when a light goes out in this room, the rest of the lights in the room remain operable. In these examples, the lights are wired in parallel circuits. In a parallel circuit, different parts of the circuit are on separate branches. Notice how there are a lot more wires in a parallel circuit than in a series circuit. The separate branches allow the current to take several paths in the circuit. In this parallel circuit, if one bulb goes out, the other bulbs stay lit. The circuits in most buildings, including your home, are wired in parallel. Let's now take a closer look at some of the other features of circuits in your home.
All right, I want you to get on the simulation, and I want you to do the lesson that the to-do list says to do. It will be talking about the difference between series and parallel circuits, so you can build your own and see what the difference really is. Good luck. Let me know how it goes.